Hey, hi everyone. So welcome again to Math 727. And for the succeeding videos, I will discuss descriptive statistics. So let's get into it. What are the intended learning outcomes? So we have a variety of intended learning outcomes. And in general, we want to determine the mean, median, and mode of a given data set, as well as the range, variance, and the standard deviation, and even a coefficient of variation. Solve the and interpret the percentiles, deciles, and quartiles of a given data set. Solve and interpret the measure of skewness. Construct the five-number summary and the box plot to visualize the data. Okay, so the outline here, we will discuss the ungrouped data measures and the group data measures. So for the ungrouped data measures, we have the measures of center, dispersion, empirical rules, the measure of relative position, the box plots, measure of skewness, and outliers. So before we dive into our topic, let's review what we have learned so far. So previously, we've discussed the population and the sample, also the parameter and the statistic. So what are the differences between the two? And we've described the different methodologies for sampling. No? So simple random sample and so on. And also the data collection, also collection using surveys and so on. And then we also discussed the frequency distribution for data summarization. Okay, so um, uh, with regards to the two general uh, categories of statistics, we have the descriptive statistics, and this will be the focus of this topic. No? And later on, we will also discuss the inferential statistics. Yeah. So the first one to describe, no, so we have this descriptive statistics as a way to describe our data. The first thing that we should learn is the measures of center. So what is the central tendency of the data? We could describe that using the mean, the median, and the mode. So for the mean, we have this measure for finding the average, or to be specific, the arithmetic average. So we have the symbol X bar for sample mean, and we have mu for population mean. So how do we get this, or how do we extract this mean from the data set? So we have a formula now. Basic formula is we have X bar is equal to the summation of X over N. So the summation basically means that we have to sum this data set, no? The sum of X, the sum of this data set. And then over N, where N is the number of data set in the sample. So we have a different way to calculate the population mean. So for the population mean, it is generally the same, no? The same formula, but we describe this mean as mu, and n on a larger or a capital N represents the number of data in a population. So what are the advantages of utilizing mean? So we have a way, no, or a reliable way to measure the average, no? Okay. But the problem here is that some extreme values can largely affect our mean. So if you have a very high or a very large number, compare this to your average, it will get higher, no? So there will be an imbalance if there is an imbalance in the data set. No? Okay, so moving on, we have also the median as a way to measure the central tendency. So it is basically just the middle value. So nothing more, nothing less, the middle value of the data. So how do we find the median? Okay, there's a lot of things to read here. But there are only two scenarios, no, that we should take note of. So if the data value or the data set is an odd number value, or the number of data is an odd number value, or if the data set is an even number value. So if it is an odd number value, you just find the middle, no, exact middle of the data, assuming that you organize this into it's ascending order or descending order. Okay, and then if the data set is even, so the number of data is even, then you want to find the two middle values and then find the average or the mean of these two numbers. So for example, we have the following data set. So the first one, the uppermost one. So if we want to find the median, we want to first rearrange this data set into its ascending order. And then looking at this, now inspecting this, we can see that the middle value is 0.73. Therefore, the median is 0.73. So if the data set is even or an even number, so for the second example at the bottom, we have 6 data sets or number of data points. So we have to take note of the um, two things now. So first, we have to arrange this into its ascending order, and then we can find the average of these two middle values. No? So therefore, the median of this data set is 0.915 by averaging these two values. Okay, and then the last one, we have the last measure of central tendency. We have the mode, which represents this most frequent value in the data set. So it could be there could be a scenario wherein we have one mode, or there is a data that always repeats, or the one that repeats the most, and then we have two data that repeats the most, and then three or two or more data that repeats the most. So it can also have no mode. Or your data can have no mode, so no similarities. So let's have an example of what do you call this? The mode of the data set. So for letter A, what is the mode of this data set? So there's only one data that repeated, no? So the mode here is 1.10. So it is unimodal since it only has one mode. And then for letter B, so 27 repeated 3 times and 55 repeated 3 times. So this two values has the same number of repetitions. Therefore, they are the mode. No? And they are bimodal. So we will not include here 88 since the most repetition is still 3. And then for the last one, we do not have a repetition, so this data set has no mode. And to add to this, no, actually we have another one. The last one is the mid-range. So basically, the mid-range is just it is like the average, no, or the mean, but we are just taking account the maximum and the minimum values. So the mid-range of a data set was just the maximum value plus the minimum value over 2. Okay, so let's move on to dispersion.